right. So first off, we are doing lesson 2.3, key features of functions. I would like you guys to open up your journal and write your I can statement from your journal. What is your I can statement from your journal? I can statement. So look at your little pink sheet, your half piece of, like that half sheet of pink paper that says Unit 2 I can statements. Actually is the lessons listed for Unit 2. What is the I can statement for lesson 2.3? What are we trying to do here today? Yeah, read it out. I'll write it in here.
I can determine behaviors of a function over a given interval. I can identify key features like maximum, minimum, y-intercepts, and x-intercepts.
So I can determine behaviors of a function over a given interval. Does it say domain interval or just interval? Okay. And I can, will you read that second one? I can identify. Thank you. Key features of a function like maximum, minimum. Does it say increasing, decreasing?
Maximum, minimum, y-intercepts, and x-intercepts.
Thank you. Y-intercepts and x-intercepts. I like the short chair. I don't know why, it's just comfy. Raise your hand if you need more time with that. All right, so we're going to talk about some vocabulary terms. This is where I would grab my highlighter because these are important. You're going to see these terms all of the time. All of the time. So the first term that we're going to talk about is the zeros. The zeros of a function are where the graph crosses the x-axis. It's where the graph crosses the x-axis. What is the y-intercept? You guys have graphed functions before. What is the y-intercept? Where the what? Where the two lines meet? What do you mean by that? Where two lines intersect? That's just that would be a solution to a system. What is the, if the x, what is the y-intercept? What do you think that is? What happens when x equals 0? If you were to look at a graph, what happens when x equals 0? What is the graph doing? That's if you have a vertical line. I'm saying, like, if you have a graph where the graph crosses an x, the y-intercept is where the graph crosses the y-axis. It's where the graph crosses the y-axis. When we talk about zeros, where the graph crosses the x-axis, these are also called x-intercepts. They are also called x-intercepts. So you have x-intercepts where we cross the x-axis, and you have y-intercepts where you cross the y-axis. Okay? What do you guys remember about slope from last year? Nothing? Huh? Y equals mx plus b, that's an equation, yeah. What else? So what does slope mean? Yeah. Yes, slope is the slant of a line. So if a graph is increasing, if it's increasing, as x gets larger, y gets larger, this means that it has positive slope. And your line is going to look like this. It's going to slant upwards, okay? If a graph is decreasing, so as y or as x gets bigger, y gets smaller, that means you're going to have what kind of slope? Yes, you're going to have negative slope. So negative slope looks like this. So if you think about the x-axis runs horizontally, right? So as x is getting bigger, as x moves to the right, y is getting bigger. That's positive slope. But when you think about negative slope or decreasing, as x is getting bigger, as x moves to the right, y is going down. That's what that means, okay? We have a thing called a turning point. And a turning point is the point on the graph where the function is changing direction. It's where the function is changing direction, meaning it goes from increasing to decreasing or from decreasing to increasing. That's like a little vice versa thing up there, okay? What do you think the minimum is? Yeah, the minimum is just the very lowest point on the graph. The minimum is the lowest point on the graph. And that means that the maximum is the highest point on the graph. Absolutely. Okay. So often you will hear the value of the function is. So when you see a phrase like this, the value of a function, this is referring to the y coordinate. It's wanting to know what the output is. It's asking you about the output. Okay? The y coordinate or the output. The domain interval of a function, the domain interval is talking about the x coordinates. And that is your input. Remember that your y coordinates are along the y-axis, which is vertical, and your x coordinates along the x-axis runs horizontally. This is your x-axis, and this is your y-axis. So we're going to look at graphs, and I think that maybe a highlighter or a colored pencil or something is going to be helpful. I'm going to try to do each key feature in a different color, just so when you guys use this as a reference or you look back at it, it might be helpful. Is everybody good with this? Okay. All right. So we have a function shown in the graph below, and we're going to answer some questions about it. So it says find the minimum. Well, remember the minimum is the what? The lowest point on the graph. So my minimum is right here. It also asks us to find the maximum. And our maximum is the highest point on the graph. So that would be right there. Can you guys see that in the gray highlight maybe? So it's asking for the minimum value. So we have that phrase value. And when we see that phrase value, it's asking for the y value. So the minimum y value is what? If I look at the minimum that I have highlighted in yellow, what is the y coordinate for that?
It's -1.
This is -5. I'm down one below it. -6. Okay. And it happens when, or it happens at x equals, so you get your minimum of -6 when x equals 2. Good job. You get your minimum when x equals 2. I can just kind of follow this up. Let's look at our maximum value. Let's look at our maximum value. So our maximum is right here, up at the top. And our maximum value is what? What is the maximum value? Yeah, what is it? I heard someone say it. It's 8. I got to get rid of that box around my screen. There we go. It's 8. And it happens when x equals what? -5. What is the y-intercept of the function? The y-intercept. So remember, the y-intercept is where my graph crosses the y-axis. So what is the y-coordinate where we cross the y-axis? What is this point right here? Y equals what? Yeah, y equals -2. That is my y-intercept. What is the x value when we cross the y-axis? What is the value of x when I cross the y-axis?
I wasn't ready.
Okay. So here's my y-intercept right here in blue. What is the value of x? If I follow this up, what is the x coordinate there? It's right in the center of the graph. What is that? It's 0. X equals 0. And if you go back to the front, when we defined y-intercept, when we actually defined y-intercept, we said it happens when x equals 0. Do you see that? The y-intercept happens when x equals 0. Okay. So could we write this as an ordered pair? Could we write the y-intercept as an ordered pair? Yeah? What would it be, Ariana? What comes first in an ordered pair, x or y? Good job. 0, -2. Awesome. So for question C, it says that we need to circle and state the x-intercepts of the function. So I'm going to go back up to my graph and I'm going to circle them. I'm going to circle where my graph crosses the x-axis. Ding, ding, dong it. This pen is being crazy today. So I cross the x-axis right here. And I cross the x-axis right here. What do we know about the x-intercepts, also called zeros? They happen when f of x or y is 0. So what are those points if we write them as ordered pairs? What are those 2 points that I just identified?
They are -1.
-1, 0, and
Positive 8.
good job. So your 2 zeros, if we write them as ordered pairs, are the ordered pair -1, 0, and 8, 0. Remember, we know that the x-intercepts, when we cross the x-axis, we know that y equals 0, or f of x, because that's the same thing. So this is a question about a domain interval. So it says, would you classify this function as increasing or decreasing over this interval of -5 is less than x is less than 2? So this is talking about looking at the domain values. So we have to go up to the x-axis, and we have to find -5 to +2. And let's see if our function is increasing or decreasing at that point. So x is -5 and x is +2. That's this whole zone. This whole zone. So we're just looking at the line, the graph that runs through this pink zone. We're just looking at the graph or the line that runs through this pink zone. Does the graph that runs through this pink zone have positive slope or negative slope? Yeah, because as x gets bigger, y is getting smaller. So that means it's negative slope, which means is it increasing or decreasing? It's decreasing. So it is decreasing. I'm going to say because as x increases, I use an arrow to mean get bigger or increase, y decreases. I can also look at the ordered pairs. Do you guys remember making a table of values? When x is -5, what is my output? When x is -5, what's my output on that graph? 8. Okay. And when x is 2, what is my output? Yeah, I think it is -6, right? So we know that x is getting bigger. We're getting bigger on the x-axis. But what's happening along the y-axis? It gets smaller. So if you didn't have a graph, but you had a table of values, you could still identify the interval over, you could still identify what was happening over a domain interval by looking at what's happening to your y-coordinates. Are they getting bigger or smaller? Okay? Question E says give one interval, so that's going to be, again, we're going to use x, like the x-coordinates. Give one interval over which the function is increasing. So I'm going to go back up to our graph, and I'm going to highlight in light blue where the function is possibly increasing. So increasing means it has positive slope. So my line has positive slope right here, and that's the interval highlighted in blue. My line also has positive slope right here. So there are two options. There are two options. We could say that from -8 to -5, or we could use the interval 2 to 9. So let's write both of them. So -8 to 5 or 2 to 9. So the interval where it's increasing, -8 is less than x is less than 5. And the other one, oh, that's -5, sorry. -8 is less than x is less than -5. And 2 is less than x is less than 9. Do you notice that when I talk about whether it's increasing or decreasing, I'm going to rewrite that because I didn't like the way it looked. Less than 2, dang it. Less than x, less than -5. Do you notice that when we talk about something increasing or decreasing, I'm not including the number -8, and I'm not including the number -5, because if I was, I would have a line underneath my inequality, right? Does that make sense? So let's look at what's happening when x is -8 and what's happening when x is -5. So that's a really important idea. When x is -8, is this graph increasing or decreasing, or is this a turning point? Just right here. What's happening at this point? It's a turning point. What's happening here? It's a turning point. What's happening here? It's a turning point. What's happening here? It's a turning point. So that's why we don't say, we don't include those numbers, because nothing's happening when X is actually -8. The direction is going to change right there. So at a direction change, you don't include those. I know this is new concepts. We'll keep practicing. So question F says, state the coordinates of all of the turning points. All of the turning points. So our turning points, remember, are where the direction changes. It's where the direction on your graph changes. And then we have to label them as a maximum or a minimum. Okay? So I'm going to go back up to my graph. And I'm going to try to find all of the turning points. Well, I know that I have a turning point right here. And I know that I have a turning point right here. These 2 points, the graph stops, so they're kind of like terminal points or end points. But I know for sure this is a turning point, and it's a maximum. And I know that this is a turning point, and it's a minimum. So we just have to label those ordered pairs. We're going to label those ordered pairs. Did you guys see that? So you have a maximum at the turning point -5, 8, and you have a minimum at the turning point to -6. So we're going to write those down. So what are the turning points? Well, you have a turning point at -5, 8, and we said that that's a maximum. It's the highest part on the graph. And you have a turning point at the ordered pair -2. It's not -2, it's +2, -6. +2, -6. And that was the lowest point on our graph, or a minimum. All right. Question G says, give the interval over which the function is negative, meaning f of x is less than 0. Okay, so that means that all of the y values are less than 0. So let's go back up and look at our graph. Let's find all of the y values that are less than 0. So where does that happen? Well, that happens when the numbers lie below the x-axis. So this green part that I'm shading in, that's where the function is less than 0, because the outputs are negative. Okay? The outputs are negative. You get negative y values there. So where does that graph first start to go below the x, or below the x-axis? What is the x coordinate where it first starts to go below the x-axis? What is this coordinate right here? X is what? 1. It's -1. X equals -1. And where does it start to come above it? What's the coordinate where it's going to emerge above the x-axis? What's this point right here? Owen?
No, +8, 0.
Yeah, x equals 8. Aren't those zeros of our function? Aren't those actually places where the graph crosses the x-axis? So when you think about crossing the x-axis, that's where you're going to decide if your function that lies below it or above it is going to be positive or negative. So at the zeros, your function either goes below the x-axis or it goes above it. So in between these two zeros, in between the 0 of -2 and the 0 of 8, our function is below the x-axis, meaning that it's got a negative output. So the interval is between -2 is less than x is less than +8. So these are your x values. In between the space of -2 and +8, not including those, right? Because at -2, y is 0, and that's not positive or negative. At 8, y is 0, and that's also not positive or negative. Just in between those 2 points, in between those 2 numbers, that graph is going to be below the x-axis. Thoughts? Have you guys ever dissected a graph like this before? Thought about all the pieces of it, what it's doing? Some of you yes, some of you no. Okay. So let's go look at example number 2. Let's go look at example number 2. So example number 2 gives us another function, and we're going to answer questions about this function again. So it says find the value of g of 1. So g of 1, that just means when x is 1, what is your output? What is your output when g is 1?
6.
Yes, good job, Owen, it's 6. Minus g of -1. So what is your output when x is -1? What is that? When x is -1, I hit the point right here, and what does that equate to on the y-axis? What's my output? 2. So g of 1 minus g of -1 equals whatever 6 minus 2 is. So what's 6 take away 2? It's 4. All right, now we're looking for the y-intercept. We're looking for the y-intercept. Where does my graph cross the y-axis? Owen?
So if it crosses the y-axis, then it'll cross, hold on. Let me think about this. It'll cross at -2.
That's where it crosses the x-axis. I want to know where it crosses the y-axis because it's a y-intercept.
The y-axis at 4.
Perfect. It crosses the y-axis at 4. So y equals 4. This is where I'm crossing the y-axis. Ariana told us how to write that as an ordered pair last time, so we're not going to let her do it this time. We're going to call on Tim. Tim, how do I write my y-intercept as an ordered pair? What is the x-coordinate at the y-intercept?
Y-intercept is 4.
What is the x-coordinate when I cross the y-axis? Look at the definition of y-intercept. Zero. So this is the ordered pair 0, 4. X equals 0 when you cross the y-axis. That's important. X equals 0 when you cross the y-axis. That is super important. Question C asks us to state all of the zeros of the function. I forgot what zeros are. What did we say zeros of a function are? It's the same thing as what? Yeah, good job, Aiden. It's the same thing as the x-intercepts. And we know, what do we know about the x-intercepts? Do we know anything about them? Like, do we know what y equals at the x-intercept or a 0? Let's look at the definition of zeros again on the front. Zeros, where the graph crosses the x-axis, and what does it say in parentheses? Right below it.
Y equals 0.
Yeah, y equals 0. So we are going to circle the spots on the graph where I cross the x-axis. Well, I know that I cross it right here, and I cross it right here. So what are those points? What's the first one?
-2.
So -2 comma 0. And what's the other one?
And the other one is +6, +6, comma 0.
Good job. 6 comma 0 and -2 comma 0. We could also just say, much like that y-intercept, we could just say it crosses when x equals -2 and it crosses when x equals 6. I want you to know both ways because sometimes it'll ask you for the ordered pair. What is the order? It'll say, what is the coordinate, which means ordered pair, of the x-intercepts? And then sometimes it'll just say, what is the x value? Okay. Question D says, state the interval where your function, your graph is greater than 0. That means it lies above the x-axis. So let's go up here and look. So remember that when you cross the x-axis, you're changing from positive to negative. So in between these two numbers, my graph has outputs, my function has outputs that are positive, right? My graph is negative between this interval and this interval. We're trying to find out the two x values, or between what interval is the function greater than 0, meaning is the function positive. So between what two x values?
Okay, so that would be +2, 8.
This is so what number is this?
That is -2.
And what number is the other one?
That is +6.
Okay, so the interval over which g of x is positive is -2 is less than x is less than 6. So now we have to talk about when the function is increasing or decreasing. Remember that increasing, my graph goes like this. Decreasing, my graph looks like this. Increasing, as x gets bigger, y gets bigger. Decreasing, as x gets bigger, y gets smaller. Okay, so let's see if we can find a place on our graph where our line slants upwards. Let's see if we can find a place on our graph where our line slants upwards. Remember that we're always talking about x getting bigger. So we read a graph from left to right, just like a book. So if I were to start here where my graph begins, am I climbing up a hill or am I climbing down a hill? I'm climbing up. So this is increasing. Because I'm going up. But then I get to the turning point, and what happens? I start decreasing. Meaning I'm going down. So between what x values is the graph increasing? So what is the smallest x value where it starts to increase, and where does that increase stop? Meaning, where does it hit its turning point? We want those x values. Well, it starts to increase when x is,
-3.
and it turns when x is 2.
+2.
So increasing is from the interval -3 is less than x is less than 2. So when x is 2, when x equals 2, that's a turning point. Tim, stand up if you're going to keep nodding off. When x is 2, that's a turning point. So I know that it's going to change direction. So I know that my next interval is going to start with 2. So 2 is less than x is less than. Where does the graph stop? What is the x value where the graph stops? Well, the graph stops right here. What is that x value?
That's positive 8.
There you go. So it's decreasing from the interval 2 is less than x is less than 8. It's decreasing from the interval 2 is less than x is less than 8. Daniel, you with me? Do you need to stand up? All right. Example number 3, we're going to create a graph. We're given specific key features, and we have to draw the graph. So we're given specifics about key features, and we actually have to draw the graph ourselves. Okay? And I know that we can do it. So let's see. So the first thing that I'm told is that h of negative 9 equals 3, meaning when I let x equal 9, my output is positive 1, 2, 3. That's going to be a point on my graph. When x is negative 9, my output is 3. I want everyone to plot that point. The other thing I know is that h of 9, when x is positive 9, my output is 5. So those are just 2 ordered pairs, right? This is the ordered pair negative 9, 3, and this is the ordered pair 9, 5. So we've plotted those 2 points. It says that we have zeros at x equals negative 7, so I'm going to plot these points right on the x-axis because that's what zeros are. So I'm going to plot a point at x equals negative 7. I'm going to plot a point at x equals negative 2. I'm going to plot a point at x equals 4. And I'm also going to plot a point at x equals 8. How are we doing? Okay. Now our graph has to turn. It's going to have some turning points, right? So it says the turning points happen. The first one happens at the ordered pair negative 4, negative 9. So negative 1, 2, 3, 4, all the way down to negative 9. This is a turning point where my graph changes direction. This is a turning point. I have another turning point at the ordered pair 2, 6. And then I have a turning point at the ordered pair positive 6, negative 2. The last thing I need to identify is my y-intercept. My graph crosses the y-axis at 5. My graph crosses the y-axis at 5. Okay, so this is essentially a dot to dot. We just have to figure out where we're going. Daniel, I want you to stand up. I'm not going to ask you again. Just go move over by Kenna and Ariana, and you can stand at their table. Daniel, I need you to get up and stand up. Nope, I've asked you twice. I'm not giving you the choice. Please stand up and move over there. Thank you. Okay, so this is essentially a dot to dot. Remember, we're always looking as x goes from small to bigger. So we're starting on the left side. The leftmost point is right here. So if I think about the next point that I encounter, I'm going to go down. And then I'm going to go all the way down to this turning point. I'm going to make my graph kind of like a curve, but then it goes up. Goes through 5 and it turns. The green dots are the turning dots. It kind of is like a parabola, but it's actually, this is a quartic function, so it's to a power of 4. So it's going to have 3 turning points. So once I hit this green dot up top, I have to go down again, go through 4 on the x-axis, get to my turning point, curve back up through 8 on my x-axis, and I'm going to stop at the ordered pair 9, 5. Notice I didn't put arrows on the end of my lines, right? I started and stopped right at these points because I don't have any information that says my graph goes on forever. I'm just told specifics about it, okay? So here's what your function looks like. The last question says, give one interval on your graph for which the function is negative. So what does it mean for a function to be negative? Isaac, what does it mean for my function to be negative? This is the third time we've had a question like this.
The y axis equals
The y-axis equals what?
0.
If the function is negative, it means that my outputs are what? Yeah, it means that your outputs are negative. That's what that means. So where on the graph are my outputs negative? Where on the graph are my outputs negative? Well, they're negative right here. And they're also negative right here. So we have to look at what are the x values. So it's negative between these two x's, and it's also negative between these two x's. So Aiden, give me one interval. One interval. What's the smallest x? What's the largest? What's the smallest x right here? So from -7 is less than x is less than, what's the largest x of that interval? -2. So that's one interval. Where else is it negative? Well, it's negative between these two x points, these two x intercepts. So what is that first one, Victoria? What is the smallest x value right here? 4 is less than x is less than 8. Okay.